Hello and welcome back to my channel. My name is Muhammad Mushtaba Alam and teaching science is my business. Today we are going to discuss some of the important topic of science that is called the scientific notations or exponential notations. So what does it mean and how is it useful to the science students? Let me introduce you to this topic. While doing science, we have to go on with a lot of numbers in terms of numericals and mathematical calculations. So while dealing with the numericals or the numerals, we sometimes are faced with numbers that is either too much large. It means it has too much zeros, or you may say it has too much decimal points. So in long numericals and mathematical calculations, you cannot use the effective way of mathematics. You can say and those simple methods of addition or subtraction or division, multiplication easily. I'm not talking about small numbers, I'm talking about large and small numbers. Let's suppose if I have a number here that is too much, you can say large number, it has too many zeros. So let's suppose it has a decimal point here, so it contains too much zeros. So if I want to add this number and multiply this number with a different number, then I will have to carry on a different mathematical arithmetic steps. So I will have to follow a long calculation, and it may have a bigger chance of error and you can say bad consequences. So what scientists did, they gave us an ease and by providing us a notation method that is called the scientific notation. What it is that you can actually write this number in a much smarter way. Let's suppose if I this number, if I use this number in terms of like this, if I write this number like this, 6.02 exponential 23, so you have a number which is quite smaller in terms of writing or expressing the digits, but it have the same meaning as we have for the upper number we have right here. So how is it possible to write, and what are the ways to write those numbers in terms of scientific notation? We'll cover that step by step. Let's suppose if I'm going to reduce that number into a scientific notation, what I will have to do is to move that decimal point one by step up to that point. So that point. So by going through, we'll have to face several decimal places. So here is the, let me write with different pens so that you can recognize it. So there is the first decimal place, and the second, and the third, and the fourth, and fifth, and I have sixth one, and the seventh one, and the eighth, and the ninth, 10th, 11, and the 12, 13, and the 14, and the 15, and the 16, 17, and the 18, then 19, then 20, 21, then I have 22, then I have 23. So when this decimal point moves step by step, 1, 2, 3, and you can 3, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and then 19, then 20, then 21, then 22, then 23. So the decimal point moved 23 times from to leftward from the very right of this number. So we will write that number of decimal places in terms of a superscript. You can say a power raised to the 10 to write the same number in the scientific notation. So This is very easy. Let me explain it with a different or simple number. Let's suppose I have a number and that is 1000. Let's suppose I have a number 1000. So the decimal point is right here. So how many decimal places it will have to move to scientific notation? So it will have first, second, and third. So this point will move this way, then the second place, and then the third place. So I can write the same number in terms of exponential notations like that: 1 multiplied by 10 raised to the power 3. So this is the main method, and you can do the same thing with a very small number. Let's suppose if I have to write and this is the number which is too much small. You can say the decimal point is right here, and this number is 0.30, then 30, then 30, and so on. You will have a very small number, so you can also face the difficult to solve this number while having some numerical problems and their solutions. So we can do the same with that small number, but in terms of a negative. Let's suppose if I mention the decimal points here, so you will have the same method I have mentioned there. So then 3 here, 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 and then 3 here, then 3 here, and then. So let's suppose if I write it one by one. So here 1, 2, 3, 4, 5, 6, and 7, 8, and 9, and 10, 11, and 12, 13, 14, and 15, then 16, and 17, and 18. Then I have 19, then 20, then 21, then I have 22. Means if I want to write this a small number in terms of scientific notation, I will have to move that decimal point to 22 places. So I can write this number like this: 6.02 10 to the power 22, but this time not the positive one but the negative one. Why? Because we moved our decimal point from the leftward to the right direction, means to the rightward. So this is a rule, you may have to say, and that whenever there is you can say a power is, if the power of a scientific notation is negative, it means the number is small enough to write it in the scientific notation. And if you can say the power of the 10 is in positive, it means that the number is bigger enough to write it in the scientific notation. So here I have some of the more examples. Let's suppose if I write some large numbers, not typically that much large, but to understand the concept. Let's suppose if I write a number like 60394. Remember that now, if you don't look any decimal point in a number, so it is usually at the end of the number, that is after the last digit of a number. So if I want to write this in the scientific notation, I will have to use the same method. So how many decimal points it will have to move? It has 1, and then 2, then 3, and then 4. So decimal point will move towards left, and after 6 we will have a decimal point while having a scientific notation. So we can write this number as 6.0394, and for scientific notation we must have to multiply it with the 10 to the power to the decimal points we have moved. It's 4, so we can write here 4. So keep this in mind. So whenever we move a decimal point from right to left, so the power will be positive. And if I do the opposite, let's suppose if I have a number, let's suppose if I have 0, let's suppose 0.3694. So here the decimal point is in front of next after the 0, the first digit 0. Then how many points will I have to move? Suppose if I want to move the decimal point up to the 3 places, let's suppose 1, 2 and 3. So this number will be suppose if I want to write it in scientific notation, so I will have 3 6 0 3 6 9.4 and 10 to the power minus 3, because the decimal point moved from 1 place 2 and then 3. So we'll have this notification. Scientific notification of this value is 369.4 exponential minus 3. It is the same as writing the same number without any exponent or scientific notation, or writing it in scientific notation. This is how you're dealing with the exponential and the scientific notation. Now moving further, we can have some parts of scientific notation, so we can write on heading as parts of scientific notation. Scientific notation. So notation. So let's suppose if I have a number, 6.02 10 to the power 23. Now the power is called the exponent, and this is called as base, and this number, which is comprised of 3 digits, is called coefficient. Alright, now it is clear that how to deal with those scientific notation, why we need it, and what are the different parts of a scientific notation. Now we can move on to towards the mathematical concept, that how we can arithmetically solve those scientific notations. So it is also very easy. Suppose if I want to multiply 2 numbers, so I can have the heading of multiplication of 2 numbers, multiplication of 2 scientific notations. So let's suppose I have 2 numbers. So in terms of scientific notation, suppose I have 2.0 exponential 4 multiplied by 3 exponential 3, let's suppose. So what we have to do, we have to multiply the coefficients, and then to multiply the coefficients together and the base together. So we'll multiply 2 with 3 and the bases together. So 2 3s are 6, and by applying the law of algebra, that if any 2 bases are same, so the powers are actually added. So we can do the same with those bases. So 4 plus 3. So the answer is 6 exponential 7. Same is the case with let's suppose I have 2 numbers. One is 2 exponential minus 4, and next number is 3 exponential minus 6. I will have to do the same job. 2 3 multiply 2 into 3, and the bases will you'll have to say the same base will have to add their powers. So minus 6, so 2 3s are 6, and the power will be minus 10. So I have some another examples. Suppose 2 10 to the power 6 and 3 10 to the power minus 4. So 2 3s are 6, and the powers will be added according to the arithmetic rules. So 6 minus 4 is 2. So this is our answer. And if we are going to, you can say, add two numbers, so we must have to do some another way. Let's suppose if I have two numbers and I want to add them. Let's suppose I have two numbers, that is 2 exponential 7 and 3 30, or you can say it 30 exponential 7. So now if those two numbers are, let's suppose 20 exponential 7, and we have to add those two numbers, let's suppose 30 and 2, suppose 6. Now according to the rules of algebra, you can say the base is same, but the exponent, you can say the power of the you can say the base is not same. So we cannot solve it by this way. We cannot say that it becomes 50 exponential something. So we have to change this, you can say, the exponent. Either we can reduce 7 to 6, or we can you can say increase 6 to 7. So in both ways we can do job. Let's suppose I write this value the same, but this times to make the power 7, what I can do, I can move the decimal point one place backward, so it will become 6, and due to the movement of decimal point it will add 1 in its value of exponent. So the net value will be 3.0, which is actually 3 exponential 7. Now we can add it because the bases are same as well as the exponents. So we can add it like 20 and plus 3, and the base will be same because the exponents are same. So the net answer is 23 exponential 7. So that is how we can deal with the exponents while doing the addition, and the same is the case with the subtraction. And now come towards the division part. It is also simple. Suppose I have two numbers. It's let's suppose 16 exponential 2 and 7 exponential, sorry, not 7, to make it simple, let's suppose 4 exponential 10 to the power 1. What I can do is to cancel out the denominator and the numerator. 4 4s are 16, and this power will be subtracted from the exponent of the numerator. So 10 2 minus 1, so the value will be 4 exponential 10 to the power 1. That is our answer. Now we can write the same answer as 400. Am I right? No, I'm not right. I just have to add 1 0. Why? Let's suppose if I want to remove that part from this value, I must have to make the exponent of this value as 0. So what I can do, decimal point is right here, I can move it to the rightward, so it will become 40.0 exponential as the point moved rightward. So you will have to minus 1 decimal point value, so it will be 40 exponential 1 minus 1 0, and that is nothing. So you will have 40 multiplied by 1. You know, anything, the power of anything which is 0, the power of anything that is the power of 0 of anything will become 1. So we'll have 40 multiplied by 1, the 40 is the answer. Same is the case here, you can do it here, but that is the way you can handle with those scientific notations in terms of writing it in some smarter fashion, and different parts we have studied, and how to do the multiplication of scientific notations, and how to divide those notations, and how to add them, and how to multiply them. I hope you understand what I delivered you according to this topic. So don't forget to subscribe to the channel, press the bell icon so that you can support me to deliver the same kind of lectures or better from this one. So up to next time, God bless you.